trigonometry. That's what we're going to focus on over the next 3 days. I guess I'll just mention that I prefer you being in class because, I don't know, I'm speaking over the last, going back 2 years when all this started. I do notice that when students are in class, they tend to do better. You're on task, you're following along. When you're home, there are more distractions, right? And so if you can make it to school, if you're feeling well, come to school, okay? That's my advice there. So I don't know if you noticed the booklet. If you open it, flip it through a couple of pages in that exam booklet, and the units appear in the order that they show up in the book. So it just so happens that these 3 units that we're preparing for test 1 are actually, in order, or they're right next to each other. So probability, vehicle finance, and the booklet bunches up geometry and trigonometry. It's just how they do it, and so you'll probably review a little bit of geometry if you follow that order. Okay, so let's flip through this booklet, and if you go to page 8, you'll get to the first topic that we're going to cover, which is probability. Page 8 in that yellow exam booklet, right? It's January 2020. It's the yellow one you should have picked up. And also at the same time, go to the probability section in that pink handout they gave you. And so this pink handout I've made basically just for you guys. You're the first group that gets this. Okay? So I thought I'll give you some bullets here and just mention some of the things that you should have on your study sheet, right? So if you flip through that little pink handout, you should find probability. I think it's on the second page there. Yeah, bottom of if you flip it, open it right in the middle, there's probability. So why do I have like a space underneath? Just to brainstorm. Like if I need to clarify anything here, I will do it as we go through the exam. Like I'll jump back in here and just give you a reminder of that concept here. So it may be left blank. I might not add anything to it, but I just thought I'll give myself some room there just in case I need to do that. Maybe just real quick, let's go over this. When you're talking chance and probability, there's something called theoretical versus experimental. Do you remember that? I hope so. Theoretical is in theory. What should happen? Oh, sorry. What were you going to say? Right. What actually happened after performing experiments, and theoretical is what should happen. And they're not always the same, right? EP, as it stands for experimental probability, is the importance of sample size. If the theoretical actually tells you what should happen if you perform enough experiments, like in the long run, the theoretical is really what we go with. The experimental is just, right? If it's not the same, it's then usually has to do with the number of experiments, the number of rolls, the number of tosses, the number of, you name it, you didn't quite do them right, okay? You didn't do them right, or you didn't do enough of them. So if you just joined us, the pink here and the yellow exam booklet, we're in probability. Watch this, the prediction. So, I should clarify. Some students said, hey, can I just bring this in, this pink sheet? No, you cannot, right? This is like a bonus. I give this to you so you know what to prepare. This is like the bare minimum, okay? Prediction, you take the probability times that large sample, right? And I should say that the probability should be as a decimal. You can never multiply a percentage as is by anything. You always have to divide by 100. We use the theoretical probability. So maybe let's do this, so you're not confused. Like, what is TP and what is EP, right? So experimental probability, theoretical probability. So the theoretical, that's the one we use to make predictions of a given choice. There's one exemption of that. Surveys, when you do surveys as to who people want to vote for, you take that experimental, the sample size, you base it on that to make a prediction. But if it's card games, dice, you name it, wheel, spinning a wheel, drawing from a bag of marbles, anything like that, we always base it on the theoretical, not the experimental. Okay. Odds, you have to know to convert between odds and probability. There are handouts that I gave you. Highlighter doesn't really work that well on this pink one, that's why I'm underlining. But you need to know how to go from odds to probability. I don't have my booklet handy, but there. If you go through that probability booklet, I show you how to do that. Maybe let's add that here. To go from odds to probability, right? So if you were to say odds of rain, let's say, okay, if a question says the odds of it raining, let me just focus here a little bit, it seems like I'm off there. Right, if it's the odds of rain says 3 to 5, like this, then the probability of raining, right, to go from here to there, right, probability would be, you take this is telling you that there's a rain happens 3 times out of, and you don't go out of 5, you go out of 3 plus 5. You always add up both sides of the odds to get your total. And so that would be 3 out of 8. Okay. And then we go, I'll box this in. And then you go probability to odds. If you want to go the other way, let's say the probability of drawing a red marble. Probability of red. Let's say it's 13 out of 27. You're on the yellow exam booklet and the pink handout. I'm just writing something down under the probability section of that pink handout. If you wanted to go to odds, odds of red, odds in favor of grabbing a red, you take the 13, and the biggest mistake is students just doing this. You're so close, yet you're so wrong. I don't want to pick on you. I'm not saying you don't know what you're doing, but you're violating the fact that for in odds, it's what happens and what doesn't happen, right? So if there are 13 red, then we take the 27 total and we subtract the 13 we've already put down on the left side. So it's 13 out of 13 to 14. Okay. And just to clarify, the 13 in this case represent the red marbles. And what do the 14 represent? Sorry? The others, or not red. Okay? We don't know if they're white, black, whatever, but we just know it's not red. So odds always tell you the event in favor and against, right? So that is in a nutshell. These are very important concepts, and they actually can be done in like half a minute probably. If I ask you this, convert it to odds, it's very quickly done, but you gotta understand how to get there. And so it's very important you do that. That's probably this is something you should go look back and look at some examples on how we did that. I gave you specific handouts for that as well. Another thing I want to talk about is expected value. You got to know how to calculate that, and that if your answer is positive, you tell me that a gain is expected, meaning it's a good idea to play. The number itself, how big or small it is, doesn't matter. If it's positive, you should be playing. A gain is expected. If it's zero, you're expected to break even, so it really doesn't matter. And negative, you're expecting a loss. So then you would not want to be playing that particular game or making a bid for that contract, so forth. Remember that if probability of winning is 1 out of 200, then automatically from this we assume that the probability of losing would be 199 out of 200, right? So the win and loss combined add up to 100% every time. Dependent versus independent, that's a big topic, right? If there is no replacement or the total changes, we know that we're talking about dependent events. Okay. Let's do an example here. So example, 3 red, 4 white, and 5 yellow marbles. Okay. Probability of getting a white. Right? Probability of getting a white would just be 4 out of, you add them up, 3 and 4 is 7, plus 5 is 12. No need to reduce, right? It'd be 1 over 3, but we go with that. B, odds of yellow. If I asked you to state the odds of getting a yellow, you go and get your yellow there. And you can just add up the ones that aren't yellow, which is 7, right? 3 reds, 4 whites. Or you can just take your total to use the same method we used before and subtract the number of yellow marbles that you have in this example. So that'd be 5 to 7. Okay. This would be the correct way of answering a question involving odds. If first marble was white, not replaced, okay. If the first, I'm summarizing here, if first marble was white and it's not replaced, that's huge, right? Then find the probability of getting a red. So sometimes the second event, all that changes is the denominator. Sometimes it's both. So if the first one was a white marble and you did not replace it, automatically you're down to 11 marbles total, right? So this is for sure gonna be effective. From 12 we go down to 11. But the number of reds has not been affected by the first event. So you just go 3 out of 11. Okay? What if it says probability of another white? Right? Probably getting another white. Still, the first one was a white. You did not replace it, so your total is out of 11. You used to have 4 whites at the beginning. Since you grabbed a white, that goes down to 3 as well. Okay, and let's do this for ourselves here. That number, we went 4 minus 1, and to get that number, we went 12 minus 1. Okay, so that's how you tackle those types of questions. I will say this, dependent. Because of the not replacing it. All right. Okay, so that's that. Now we're gonna go into the booklet and work through some probability questions. There are on page 8, 1, 2, 3, 6, 7. Yeah, so I'm gonna let you do this first, okay? You're on your own now. I'm letting go of your hand, right? We took off the training wheels, and now I'm rolling you off into the unknown, all right? So go to page 8, and today I'm focusing on probability. Tomorrow I'm going to focus on trigonometry and then vehicle finance towards the end. So that's the beauty of these are the 3 units right here. Yeah, so today this, tomorrow this, vehicle finance because it's going to be the heaviest. Maybe I'll do vehicle finance tomorrow. You have 2 days to kind of a lot of similarities with the interest and all of that, yeah. Except for when you buy used and new, right? Like the taxes and all that, that's a little different. Yeah, well, the vehicle finance, we didn't do insurance because it's a little bit more, it's harder to do with vehicles because it depends on the type of car and, right? Like, no. Mortgages and loans they work exactly the same way because they're both loans, just mortgages are bigger amounts, and you take longer to pay it off. That's about it. Okay, so do probability. Oh, I want to say this. I need to ask you again. Did I give you a pink booklet first or a green one? Pink? Okay. If you're done probability in this one, go to your pink one, look up probability in that one as well. Because I will go over it. I'll post those keys if I don't get to all of it. But both booklets have a probability section. Okay? So do the yellow one now. I'll walk around. So here we go. Ready? So fill this in. I usually do more than just the question. Just I use it to help you understand what else could be coming your way. Okay, so Sonia won a prize in the contest. All prizes are listed below. 12 t-shirts, 7 jerseys, 6 gift cards. Calculate the probability. Highlighter, if you can bring a highlighter to the test, that'd be great. Right? First of all, it's probably not odds as a percent that she won the t-shirt, right? So I will make a note here. If you add this up, right, this is 19, this is 25 items, right? You always need, probability is always event over total, always. That's what's unique about probability. The total is under the whole thing. So probability of a t-shirt right? How many t-shirts are there? There are 12 out of 25. You wouldn't get the full marks there. Why? They want it as a percent, right? So you grab your calculator. I have it tucked away because I was doing marking home, right? So about 50%, right? 48%. So that's 48% if you multiply that by 100. So always multiply whatever you get by 100 and go up to 2 decimals. If this had been a decimal, you would have had to include that, okay? It just happens to be a perfectly round. And I can't help myself but to say, what is odds of winning t-shirt? Well, there are 12 t-shirts, and you can either say, well, I'm going to take the total and subtract the 12 from it, or you could have just gone, right, 12 t-shirts and then add these two up to get you the non-t-shirts, basically, right? So 12 to 13. Odds against t-shirt. What if it said odds against? Never. Oh, don't reduce a fraction. If it just said find a probability, you could have stopped right there. If you reduce and you make a mistake, then it will cost you. So don't reduce just for this test, right? Don't do it, okay? Just leave it like that. It ended up being as a percent, so that's what it ultimately wanted. Against t-shirt, what you want to do if it says the word against, you want to put the t-shirts on this side, on the other side of the fence, like against you, right? And then you do the 25 minus 12 here. So it'd be 13 to 12, right? Because of that, you put the t-shirts are on this side, right? So whenever you see that word against, just flip it basically, right? You want the event, in this case, which is the t-shirt, on the right side of the fence. This is what I mean, I go above and beyond, right? Because I use this question to just make more. And it's much better if you want to review to see everything, right? All right. Good. Next page. So 1 mark question turned into like a 5 mark question. What's up, Mr. Dirksen? Why are you doing that? Choose the letter that best completes a statement, the number that does not represent a probability. This could be a probability, right? Because it's less than 1. Remember, it can only be a total of 100%. Rain and not rain is 100%. So this cannot be, right, greater than 1 or 100%. That's why this one is not it. This would be 50%, right? We're good. So B is the letter that you want to plug in there. For probability, you cannot have bigger than 100%. Something went wrong. Okay. Next. Oh, maybe I'll say this. If you had a fraction, they could have had a fraction like this, right? Right. This would be 1.3, 1.6 repeated, right? This is also not it. Like if it's a fraction and that fraction is bigger than 1, it's a no-go, right? So you got to watch out for that. Question 9. Micah's planning an outdoor activity for her club. The weather forecast is as follows. On June 17th, probability of rain is 30%. June 18th, the odds for rain is 3 to 8. So there 3 times it will rain, 8 times it will not rain, right? Explain which data Micah should choose if she hopes to avoid the rain. always turn everything into a probability. Okay, so what we're going to do here is we're going to turn this into a probability, which is just 3 over 8. Perfect, perfect. Stop me, right? That's the common mistake. That's why I did that. It's 3 out of 3 plus 8, right? So it's 3 out of 11. That's the probability for rain on the 18th. Okay, and this is really, let's turn this into a percentage. Right, so you go 3 divided by 11 times 100, 27.27%. So then you have them both as a percentage, both are as a probability. So June 18th is the best, right? Has a lower chance of rain. 27.27% versus 30% on June. Just make your point clear, right? Sorry, June 17th. Okay, so you've shown some work and you've explained why you should pick 18th because it has a lower chance. Okay, and this involved you turning this into a probability. Okay, this is now probability. We went from odds to probability. That's what we did here. That's where that skill is very important. You could have turned the probability of rain at the beginning to odds, but it's harder to see which one is better if they're in odds. It's better to turn them both into a percentage or both into a fraction, because this is 3 over 10, right? But it's easier to see if you have them both as a decimal or percentage, in my opinion. Okay. Next page. Next question. Oh, 3 marks. Let's just skip this one. No, I'm just kidding. We'll do it. We'll do it. Allison is bidding on a computer contract. The probability of winning, a highlighter here, probability of winning is 35%. Let's just say this then. The contract is worth, right? This is basically the prize you would win is $12,500. Allison spends $1,600 to prepare her bid. Calculate the expected value. That should say something to you of the contract. Expected value is probability of winning. And here you would go the price minus the cost, right? And this would keep on going for as many ways as there are of winning. In this case, they're only mentioning the win one time, right? So then you go minus probability of losing, and that's just the cost. In this case, that's what it would boil down to. So let's go ahead and find out. Probability of winning is 35%. Write that as a decimal. The price is 12,500. The cost is 1,600. So this is what we call the gain. Okay, when you subtract that, that's really what you're gaining. Minus, what's the probability of losing here? 65, yes. So what you need to do here is, right, we come up with the 0.65. Why? We go 1 minus 0.35, which is the win, right? And that goes in here. That's how we get the loss. It's not always going to be explicitly stated. And then $1,600 here. Okay? So we took the win, we subtracted it from 1, because these two events add up to 100%, or 1 in this case. So we got the 0.65. Okay, so let's clean this up. If we go 12,500 minus 1,600, that's 10,900 minus 0.65 times 1,600. Okay, and let's clean this up even more. That is 3815 minus 0.65 times 1,600. That's 1,040. You subtract those two. That's now dollars come in, right? 2,775. That is the expected value. Okay. Gain expected from us since expected value is positive. Don't say we'll win a lot because the number is big, right? Just say expected value since the EV is positive. Okay. I'll leave it up there. If you want to copy it, I'll just leave it there for a while. Because this one, okay, on a test, if it's out of 30, it's a little bit more. It's out of 34 or so. One is 34, one is 33, I believe. 3 marks is almost 10%, right? So if you can even score 1 or 2 marks in here, you know, that'd be a great help to you overall. We're good? Next question. 2 marks, I make a note of that. So let's see. A survey company asked random people, a sample of 300 people, right, to identify their favorite television program. So it's a survey, right? And here you have your results. Calculate how many people, right? Calculate how many people would be expected to identify with program D if 500 people were surveyed. So this is a prediction question. And let me see here. My pink sheet. Just 1 second here. I'm going to block this for a bit. Prediction, you take the probability of that event times the larger sample. Okay? So prediction is probability times large sample. And this is my larger sample. 5,000 is my larger sample. So probability of program D is 1/12 over, how many people were surveyed? 300, right? Right here. 300. And we multiply that by our larger sample, which is 5,000. That's how you do this type of question. They give you, you remember voting for the different student council members? Remember that example way back when? Almost feels like ages ago. Yeah, so they did the same thing. They give you a table of the surveys, and now they can predict how many people in a larger sample would actually like this, right? Or that TV program. So you go 1/12 times 5,000 divided by 300, and that's 1866.67. Can't have that. So that's approximately 1867 people, right? You need to round to whole numbers if you're dealing with discrete data. So number of cans, number of people, number of coins, like things that can only be in whole units. And so that's how this goes. I could ask you, how many people would you expect to like program B, right? It'd be 84 out of 300 here. times 5,000. Right? So same thing there. Hope this brings back some of the questions of this type that we did. And you know what I would say is grab your probability booklet today after this and just flip through it. You know, just flip through it. It's like, oh yeah, I remember that, right? I fell asleep right here, you know. Where are my notes for this one, right? What happened here, right? So you just flip through it and see if things come back, and they will. They will. It's actually proven that if you forget something and then you go back and see it again, your brain now is seeing, okay, I made one connection back then, but it wasn't that important. So you're now making another connection. And so it's making it stronger. So you'll probably more likely to remember it for a test, right? So keep that in mind. Question 12, 2 marks. Each year, a market gardener randomly grows peas, beans, carrots, or onions. The table indicates which vegetable was grown in each of the past 10 years. State the experimental probability. There's my highlighter here. Experimental probability that you will grow beans in 2020. And that is based on what actually happened, right? So let's go ahead and find our beans here. It happened once, 1, 2, 3, 4 times. Experimental probability would be 4 times out of a total of 10. Okay? Beans planted 4 times. So that's where this number comes from. That's why they have to, if they ask for experimental, they have to give you the events that preceded this prediction that you're making, the probability. They have to do that. So they'll say, hey, Johnny rolled these numbers, 1, 5, 6, 8, right? Like whatever it is. And so you'll have to base it on that for the experimental. State the theoretical probability that the gardener will grow carrots, carrots, in 2020. And if you look back, theoretical probability, I'll actually go TP to differentiate. You need to base it on what are your options. So every year you reset. So you had 1, 2, 3, 4 options, right? So it's out of 4, and you pick one out of those 4, right? So onions, peas, carrots, no. Beans, not peas. Oh, wait, peas, beans, carrots. There you go. I got it. So 4 options, right? That's where that comes from. And only one of them is carrots. One option out of the 4 would be carrots. So there's a 25% chance that you pick carrots on any given year. But based on what happened, there's a 4 in 10 chance, right, that you'll grow next time. All right, next, question 13, 1 mark. 1 mark, and this always throws students off, like a whole page. I will not have that. Your test will not have that much space. So 1 mark should not take that long. State the odds, and they were nice enough to make this in bold, right? Odds against Nico randomly selecting a country song. So odds against a country song from a playlist that are 345 to 105. Right? State the probability as a fraction of Nico not selecting a country song. This is actually a loaded question, right? So the odds against Nico selecting a country song is this. Let me see if you're paying attention. Which one of these 2 numbers would be country songs? Left or right? Right? Right, right? Right. Uh, Anyways, so because of this, we know that country songs, this is country. Okay? So probability of not country, not country. That's what they're asking. You got to take the not country, right? And then in the denominator, you always add them up because these two give you your total as a fraction. So we're okay if we fill this, if we just complete this, that'd be 10, 5, right? 450. There we go. That's it. Don't reduce. You're done. Okay. Probability of country. They're not asking for this, but we could say 105 over 450. This is just an aside here. And these two would add up to 100%, right? Country, not country, 100%. So the word against, whatever event it happens to be, rain, in this case, country song, the word against tells you that that event is on the right side. Okay, so we have identified country where it is, which means that this is not country. And so we pick that number just to make sure we find the probability of not country, right? Oh, we reached vehicle finance, but I'm going to stop right there. Again, bring your tests, your booklets for vehicle finance and trig tomorrow. And if you go to your pink June 2016, it's always shifting a little bit. But probability is on page 8 still, right? Probability is on page 8 still. So if you want to go there and review that, I will post the key, and you should oh, I see a not replaced there, right here. We have some time. Do you mind if I do this one? Can I do this one? Yeah? You don't mind. You love hearing my voice. Not. Okay, anyways. I think some of you will appreciate. Pink. Probability. Oh, I guess I should let you get that out if you have it. Josephine has placed 3 white, 5 blue, and 6 purple marbles in a bag. You know what? I'm going to go ahead and find the total right away, because we're in the probability unit. So 6 and 5 is 11, plus 3 is 14 total. State the probability of selecting a purple marble from the bag. Go out of 14. 6 are purple. It doesn't ask to state as a decimal percent. Leave it. Okay, this is it. You know what? One that doesn't show up very often is letters. I will talk about that before you go. It's not that hard, but we did have some examples in our notes on letters. Like a letter, you have a word is given to you, and then they ask you what's the probability if you took these letters and put them in a bag, probability of getting a vowel, probability of getting an I or a T. So you just got to add up those letters. That's your total. And then just find out how many of the letters that they're asking for are also there, and you get your probability that way. A purple marble is pulled out of the bag and not replaced. What kind of event is this? Dependent, right? it will affect the second outcome. State the probability of randomly selecting another purple, right? Another purple marble from the bag. So purple would be, I know that my total has been affected down to 13. We used to have 6 purples, now we have 5. Okay, so that would be the probability of getting another purple. Second event. Okay. So we went 14 minus 1 to get that. We went 6 minus 1 to get that. So there we have it. Next question, question 8. State the odds of in favor of a tidal wave occurring, given that the probability of the event is 3 out of 147. So let's go 3 out of 147. Let's write it down like this. So we want the odds of a tidal wave. So this is, because it's written probably for this event is 3 out of 147. So 3 represents the number of tidal waves. So we go 3, 2, 147 minus 3. So it's 3, 2, 144. That you want to state there. Odds in favor. Odds against, you would simply flip it. Okay. Expected value. Try this one. We have 5 minutes. Try this expected value right now. Let's say you get half of it right. I consider that progress, right? Because expected value was one we got stuck on quite often. So give that one a try. I think I'm going to stop right here. The answers will be posted.